Hello everyone, my name is RS Singh and today I'm going to teach you quick sort quickly. Okay, so without wasting any time, let's begin. So let me tell you quickly what sorting is. Sorting is basically arrangement of numbers, and not just numbers, arrangement of a series. Okay, it may be alphabet, it may be number, it may be name, so it can be anything. So basically sorting is arrangement of series of a given series in an orderly manner. It can be ascending order, it can be descending order, or it can be in numerical or lexicographical order. If you don't know what lexicographical means, go search Google. Okay, we are not here to discuss what lexicographical is. So let's see how quick sort does sorting. Okay, basically we are talking about the ascending order. Okay, so the smallest element will come at the beginning, and the element with the greatest or the greatest value will come at the last. Okay, so as you can see, we have this list or array, whatever you want to call it, you can call it. So in this list, as you can see, 6 is the smallest element. Ideally, according to the ascending order, 6 would have been the first element, and 90 being the greatest element would have been the last element. But here in this case it is not, means it is not sorted, this is not ordered. So we'll make it order, we'll sort this using quick sort algorithm. We'll do it in the same manner as quick sort does. Okay, so let's begin. So what quick sort does, it takes we can call it 3 pointer. Yeah, it takes 3 pointer, wherein one of the pointer is called your pivot element. Okay, one pointer we name it as p element, and the third pointer we call it the q element. Okay, as you can see, you can see here there is a plus infinity here. Okay, I'll tell you why it is there. So now generally we take pivot the first element, we consider it the pivot element. Okay, and I prefer this approach for better code readability, but this is not mandatory. Okay, you can choose any element as the pivot element, this is up to you, but I recommend choosing the first element because this is how I solve it. So that we do, and then the element, or the if you are not choosing the first element as your pivot element, then you can choose the first element as your p pointer. But in this case we are choosing the first element as the pivot element, so the immediate next element is your p pointer. The p pointer will point to the immediate next element, and the q pointer will point to the last element. Okay, mind you, this infinity is not part of this list, okay, or this array. I'll tell you what it is. So what p pointer will do now, p will move from left to right. Obviously it is in the leftmost if you don't consider this pointer, and the only way to move is to the right, considering it cannot go to the pivot element, and q will move from right to left, obviously. So while moving, p pointer will search for an element. Listen clearly, p will search for an element which is greater than or equal to your pivot element. Okay, and p and pivot are different, for your information, let me tell you. And q will search for an element which is less than equal to your pivot element. Okay, now let's come to this infinity. Where does this infinity comes from? Suppose, now I told you that p will search for an element which is greater than equal to pivot. Okay, and it will stop there. So suppose your pivot is the biggest element, or your first element is the biggest element, and you took that as your pivot element. What happens in that case? So p will keep moving in order to find and trying to find an element which is greater than equal to your pivot element, which obviously it won't be able to find, because your pivot is the largest element in that case. So in that case, to stop that pointer, your p pointer, we give a plus infinity at the last, because if your pivot element is the greatest element, your p pointer comes to a rest, or stops its execution. Okay, yeah, stop searching for an element. So that's why we do this. Okay, now let's begin the execution. Okay, so now your p pointer will search for element which is greater than equal to pivot, that is your 14. Okay, and if it finds that element, it will stop there and will start pointing to that element. Otherwise it will move to its immediate right. So see, in this case, is 6 greater than equal to 14? Clearly no. So it will move to your next element. Okay, is 90 greater than equal to 14? Yes. So this will become your p now. Okay, see, this is your new p. Similarly, your q pointer, it will search for element which is less than equal to your pivot element. Is 25 less than equal to 14? No. So it will move to immediate left. Is 44 less than equal to 14? No. Next, is 90 less than equal to 14? No. Is 6 less than equal to 14? Yes. So now your q will start pointing to 6. Now see, there are 3 conditions. Okay, so in the first condition, what happens is, after your p and q have stopped, they have found their respective element, what they were supposed to find, and they have stopped there for the time being. Now in that case, you have any of the 3 of these conditions will happen. Okay, so either p or q would not have crossed, so we'll consider this sign as crossing each other. Okay, so in the first condition, p and q stops before crossing each other. Okay, in the second condition, p and q stops at the same element. Okay, they point to the same element. And in the third condition, they stop after crossing each other. So if it is the first condition, if the first condition is matched, so what we do is we switch the value of p and q. Okay, in the second condition and the third condition, what we do is we switch the value of your pivot element and your q element. Okay, this is very important to understand quick sort. So we'll see here, p and q have crossed each other. So what we do in that case, we switch the values of your q pointer and your pivot. Okay, so what will happen in that case, your q is pointing here. Currently your q is pointing here, your p is pointing here, and your pivot is this, and they have crossed each other. So this and this value will get switched. Okay, so now your array look like this: 6, 14, 90, 44 and 25. Okay, so this marks end of your first pass. Okay, now see, after first pass, you can clearly see that these 2 elements are sorted. Okay, now you can see this array being divided into 2 parts, wherein the first part is sorted and the second part is still unsorted. Now we'll divide the problem. Okay, mind you, quick sort is also considered as a divide and conquer algorithm. If you are not from computer science, you might not get these terms, so I won't complicate the thing. But in divide and conquer, what we does it, we divide a larger complex problem into smaller problems, we conquer them or we solve these problems independently, and then we merge the solved problems, and that gives us our answer, or that solves the larger problem. Okay, so here we will divide this problem. Okay, and as you can see, this is already sorted, so we will not we will not waste our time and resource on this. We'll just consider this as the as our new array. Okay, now the same thing we'll do. First element as the pivot, immediate next as your p pointer, and the last element, which is your 25. Now in this case, here we have only three elements, so p and q are immediate next to each other. Okay, and this I told you why we put this already. And we'll do the same thing. What does p does? P searches for element which is greater than equal to pivot. Q searches for element which is lesser than equal to pivot. Is 44 greater than equal to your 19? No. Next element. Is 24 greater than equal to your pivot? No. It moves to the next element. Now you see p is pointing to your infinity. You see this infinity came into use. Okay, listen, yeah, this came into use. Now this is your new p. You see, I have made this to make you understand this. P has jumped from here to here. Okay, 44 to 25, and now p is pointing to your plus infinity. Okay, p is there, p has stopped there. Now come to q. Q searches for element which is less than equal to 19. Is 25 less than equal to 19? Yes, so q will remain there. Now see which condition is matched here. This is the third condition, as you can see from here. Okay, p and q, they have crossed each other. So what we does it, we switch the value of pivot and q. Okay, so your q is here, pivot is here, we switch the value, and that gives you this array: 25, 44, 90 and plus infinity. Now we don't need plus infinity, and as you can see, this part has also been sorted. So the first part was already sorted, the second part got sorted. Now you merge both the part, and this gives you your sorted list or sorted array, sorted series, whatever you want to call it, you call it. Thank you very much.